Okay. So, like I said, you all just got a copy of this worksheet here, and we're going to go over how we're going to handle these problems. We are not doing anything as far as like new learning goes today. I'm not going to throw new shapes at you or anything like that. We're still just talking about cylinders and prisms. Those are the two things that we've talked about so far with volume. But what we're going to do is some work with like modeling. How do we take a cylinder or a prism and apply it to a situation where maybe you need to make a decision about which one's better for you, which one has more liquid in it, like this first one, or which one is a better bang for the dollar, okay, when you're out buying things. Okay, so I'm going to first, just while we get started, play a video that kind of illustrates what's going on this first problem here. Okay, so nothing too fancy in this video here, but I want you to think about right now, I want you to put in your place of what that guy said. He said when he was younger, so I'm talking when you're like maybe 5 or 6 years old, okay? And your mom or dad said, yes, you can have a pop, but you have to split it with your sibling, okay? And so your older sibling is saying, okay, I'm going to open it up, I'm going to pour it into two things. If you were like 5 or 6 years old, which cup would you be choosing? Why the one on the left? It looks like it has more, right? Okay, but now you guys are, you're in high school, you've learned a lot about how liquids can be a little bit, I would say, like you can kind of look at something and maybe have some misconceptions about how much might be in that left one versus the right one. Do we know for sure that the left one has more? Does anyone think maybe the right one has more? If you had to make a guess just by looking at them, what would you, as a older, more mature person, which one would you be picking? Would you still pick the left one, or would you maybe pick the right one now? Anyone have a preference or an opinion? It's okay. There's no right or wrong answer right now because you don't know anything about quantity. What would you grab, Quentin? The left one still? How many, just raise your hand, you'd still grab the left one? Okay. And if you think, no, I think the right one has some more. Maybe a couple? Okay. If you were going to do this, though, do you have enough information to make your decision? Not just based on the picture, I don't think. Okay, so if I gave you a little bit of information here, I'm telling you that you've got this can that holds 12 ounces. So it's just like a normal can of soda, okay? Your sister or your brother, whoever, your older sibling is splitting it with you. What else would we need to know now that we know how these shapes work? What else would we need to know about the situation up here in order to make a better judgment? The width of the glass, okay? Because what shape are the glasses in? Cylinders, okay? So the width would be like the diameter of the circle, the base that we would need. We would need to know either how long that is or how like halfway it is, right? Because that would represent what? If you were only going halfway instead of all the way across the bottom. The radius, okay? So when you're dealing with a cylinder, that's like what we just talked about on your bell ringer, it's pi r squared. You would need to know either your radius or you would need to know the diameter so that you could use that formula. Because you can always take a diameter. What else do we need to know?
Could we know the volume? We take the volume divided by 2, depending on how full the glass is.
Yeah. So I think kind of what you're saying there, Hayden, is kind of what I want us to figure out is what is the volume of each cup? Because I want to know which one has more soda. That way I'm picking the one that has most, right? I'm going to show my older sibling that I'm smarter than them, right? By picking the one with the more soda. So we want to find volume. What else would we need in addition to the radius or the diameter? The height, right? I need to know how tall each thing is of soda. Once I have those things, I should be able to find my volume, right? Be able to answer this question. Okay, so On your guys' worksheet there, I've got some numbers up here now for you. You can fill these in. So I'm giving you some of those pieces so that you could maybe figure out what the volume is of these two glasses. So go ahead and on your worksheet right now, jot down those numbers because you're going to need them when you start doing the math in a little bit. Also notice at the bottom there, they're giving you another little piece of information. They're saying that 1 cubic centimeter is equal to 0.034 fluid ounces. You might want to write that down on your worksheet because we're talking about volume of this soda. They told us originally that the can of soda was 12 total ounces. So while I could calculate my volume in centimeters, that may not be super helpful to me in this situation when my liquid that's being poured in is being measured in ounces. So that number at the bottom where it says note, I would make sure you jot that down too on your worksheet so that you can use that to do a conversion later. Okay, so in a minute, I'm going to give you guys time to kind of just dedicate all your thinking to this problem. But what you're going to do is figure out what is the volume of each cup so that we know which one's more. Like, is it a 50-50 split? Does each one get 6 ounces? Or is it 7 and 5? Is it 8 and 4, 9 and 3? Like, we're trying to figure out what's what so that you can decide which one has more liquid in it. Okay? Questions on how you're going to handle that first one? All right. So, like I said, I'm going to give you guys a lot of time to work today, but I'm going to skip ahead now to the next one. So if you look at this next problem, what are these? Trampolines. Any of you have a trampoline growing up in your backyard? And you have a trampoline in the backyard that blew away during a windstorm one time? Someone last period had that happen to them. Anyone have like a small trampoline when you were little in your basement or something? Yeah, I had one for my kids with like the handlebar on it. Do you guys know what I'm talking about? Do you guys ever have one of those? Okay. These ones are talking about like a bigger size trampoline, not necessarily just like a little tiny one. Okay, but we've got 2 different trampolines here, 2 different prices. What do you guys notice about the trampolines? Anything stand out? They're different shapes. Can you elaborate on that, Brady?
Like one's a hexagon, one's a circle.
You're looking at the bases?
Yeah.
Yeah, he's saying that this one is a hexagon, which is interesting. I don't think I've ever seen a hexagon base on a trampoline before, but they do exist because this isn't just something I made up. Okay, this is from a brand. This one is a circle, so probably more of your traditional trampoline. Okay, it's interesting that this one has a hexagon. And when I saw this like on a website, like on Amazon or something, it was interesting that the hexagon was there because, like I said, I'd never seen that in person. Most trampolines that I've ever come across have a circular base. But I wondered, like, maybe the hexagon is going to provide me with more volume, or my kids, I should say. I'm not jumping on trampolines anymore, but like my kids would be. So is a hexagon going to give me more volume for those kids to be jumping around in? Or is the one on the right, the one with the circle, still better? And maybe the one on the left just looks cooler. Okay, I don't know. So I thought, how could we figure this out? How could we figure out the volume of these 2 trampolines? Now the net are going to be kind of like the side of my 3D shape here. And I'm just going to assume for this problem that when the net is like installed, that the top where those poles kind of stick out is making the same shape. We've got a hexagon on the left and we've got a cylinder or a circle on the right side. Okay, but what else would we need to know here in order to do this problem, to figure out the volume?
Figure out the height.
We need to know the height of the trampolines. Yep. What else do we need? Think about the one on the right with the circle base. That's back to like your cylinder. If you have your height, what else did we need on our cylinder formula? Radius. So I would need to know radius or, again, diameter, because I can always get from diameter to radius. The one on the left there, it's a hexagon. What do we need to know about the hexagon in order to find volume?
The side lengths and the top.
we need to know a side length, and we need to know an apothem. Okay, that way we could use that formula that we've talked about in the past and then be able to still take it times the height. We still need the height of the trampoline. Okay, all right, good. We need all that information in order to do these problems. So here's some numbers for you, so you can go ahead and put those on your picture. Okay, if you take a look at these numbers here, anything stand out to anybody? The inches and feet, Addie said. Different measurements, right? If I'm finding volume, I probably need to have it all in a single measurement. So you have to make a decision before you even start here if you're going to work with feet or you're going to work with inches. It doesn't really matter which one you choose to work with. Okay, you can do either one, but you will need to maybe do some converting before you can handle this. So let's just really quick up here on the board. How many inches are in a foot? 12. Okay, so I'm just going to write up here 1 foot is equal to 12 inches. I'm also going to add a couple other conversions up here because I know what you're going to see on your worksheet today, and there's going to be some more that maybe you need to know. Do you guys know how many feet are in a yard? 3. Do you know how many inches would be in a yard then?
36.
Good, 36. So if you don't know those, maybe jot those down because you might see some of those conversions show up in a little bit. Okay, now let's also talk about the bottoms there because they're both 7 feet across. Now on the one on the right, we're dealing with a circle as our base, right? So here to here, like through the center, is 7. We can work with that. The one on the left, though, this is our hexagon. I'm going from like corner to corner, we're saying is 7. That's not a side length. That's not saying that this is 7. It's saying like all the way across the widest point of my hexagon. And I could really do that from any corner to corner. It doesn't just have to be this one across the middle. It could have been another one going like diagonally. I could have done that instead. Okay? So let's talk about this for just a little bit. You're going to be working with that right triangle in here. How much is this angle? 60, which means this one has to be 30. If 7 is all the way across from corner to corner, that would be known as a diameter of the hexagon. When I go from center to corner, though, that's the radius. So how long would that be in feet? 3.5. Okay, so keep that in mind when you're working with that. And again, you'll have to decide, maybe even before you start working too much with that triangle, are you going to keep it in feet or are you going to change it to inches? Once you get your total volume, you then need to think about those price points and figure out which one is giving you more volume. I want to know if I was going to buy this for my kids, which is the better buy? Which one is going to be a bigger trampoline and it's going to maybe be the best bang for my dollar? Okay, I don't want to just spend money on useless space. Okay, I got 3 kids. If I'm going to put them all on the same trampoline, they got to have plenty of space to be jumping around so they don't bump into each other. Okay. All right, so the rest of that worksheet there, like number 3 at the very bottom of the worksheet, has a cylindrical can on it. They're talking about like dog food. You're trying to, again, figure out which can of food is going to be the better for like better amount for your dollar. Okay, so you're working with unit cost. And then the back problem, this is talking about stairs, okay, that they're installing next to a house. It's split into 4 parts. Make sure you work through them like consecutively. Start on A, then go to B, then go to C, because you'll need some of the information from A and B to help you do the later ones. And again, there's an application of you have to buy paint and you want to spend the least amount of money if you can. So you want to think about what would be the best option there. Okay, so these problems that you're going to be working on today for the rest of class, I'm going to give you time to work on these worksheets, or this worksheet, just one. You're going to be trying to kind of apply what we've been learning about the last couple of days to these situations where we're trying to figure out which is the better trampoline to buy, which glass has more soda in it, those kinds of things. All right, so I'm going to give you guys the rest of the time. You've got about a half hour, a little over that, to work. You can move around, work with a partner. If you have questions or you're stuck, make sure you ask, but let's use our time accordingly. This is going to be due tomorrow.